Hello everyone, my name is Travis Hadlock. I am a student at Embry-Riddles Aeronautical University. I am currently trying to obtain my Bachelor's of Science in Engineering, and this is a video presentation for my Module 7 lab for instrumentation and data acquisition. This lab is going to be the investigation of using a thermistor, which is a sensor that changes its resistance based on temperature. And we are going to filter this resistance through a program called LabVIEW that is going to change the resistance to a temperature reading. And then finally, we are going to have an LED that signals to us if our temperature is greater than 70 degrees Celsius. So, in order to start, I will go over the LabVIEW application and the program that we have built for it. And then I will quickly show the hardware setup that I have, which is simply going to be the thermistor going directly into the myDAQ from National Instruments. So to begin, we will talk about the LabVIEW program. So here we have what is called the block diagram for our program in LabVIEW. The block diagram is effectively the behind the scenes of your application. It is where you do all of your signal manipulation and conversion in order to do what you want the program to do. So on the left hand side, we start with our DAQ assistant. This is effectively the block of the program that communicates with your data acquisition hardware. So that block is what actually takes the signal from the myDAQ and inputs it into your program. So we can see that we go through a series of different manipulations here. All of this is doing is taking our resistance and converting it into a usable number. So with just resistance, we can't really say what the temperature is based on just the resistance. So we use this formula in order to take that resistance and transform it into a temperature. So the output of this formula node is down here, and it is in the form of a temperature in Kelvin. So we have a display output right here, temperature Kelvin. We will see that on the front panel when we get to it, as well as this temperature in Celsius and then this temperature chart. So if we kind of follow along our wiring here, the temperature in Kelvin goes to that display, but it also splits off down here to this. This is just a math function. All it's doing is it's subtracting this value from this value. So we have our value in Kelvin. We know that we need to take 273.15 out of it in order to convert it into degrees Celsius. So once we've done that, we can send this degrees Celsius into a display output as well. And then we are also going to send it to a chart so that we can continuously record the temperature in degrees Celsius as well. From here, we also have another wire that's going to split off from our degrees Celsius, and it's going to go into this comparison block. This comparison block is really just taking this signal. It is comparing whether or not it is in between 70 and 100. If it is in between 70 and 100, it is going to output a signal to our LED to make it turn on. So that pretty much wraps up the entirety of the block diagram. And from there, we can look at our front panel and talk about that. This is a little bit more simple of an explanation in regards to how this works. The front panel is effectively like your front-facing part of your program. You will have things like, charts, displays, LEDs. You can also include things like knobs, buttons, controls as well, so that you can actually use your front panel instead of having to like manually adjust things in the block diagram. So from here, yeah, we have our temperature chart that I had mentioned before. So our degrees Celsius is going to just plot over time on this chart. Here we have our two displays, temperature in Kelvin, temperature in Celsius. And then lastly, the thing that we wanted the program to do was to blink a green LED if our temperature is greater than 70 degrees Celsius. And so that's what this big green button is here for. I can actually manually click it on and off. But what we want this program to do is to blink on and off using the resistance. So we'll get into that next. So the last piece of this lab is actually the hardware setup and the lab activity itself. So here we have our myDAQ from the Texas Instruments, and we have our two lines running out of the ports on the bottom. These are going to run to the thermistor that I have alligator clipped on here, and then we have some room temperature water and some hot boiled water here. So all we got to do is actually just start our program here, and we are going to see our temperature in Kelvin and Celsius is going to start to read. And all we got to do is put our thermistor into our hot water and see what the temperature is and see if it triggers our LED. And there we go. We can see that the temperature of this hot boiling water is somewhere around 71 degrees. It is cooling pretty rapidly though, so we are sitting at right about 71, in between 69 and 71, so the LED is actually flashing because we're floating right around that 70 degree mark. So as maybe we hit warmer or colder pockets of the water, we're going to see it go up and down, and I think we are just about out of enough temperature to keep reading. So we can take it out, put it in our cold water, and we'll see that that temperature Celsius is going to drop way down. And just for sake of testing how accurate this is, we can put it back in and see that it's going to, pulled it out a little bit there, but it jumps back up to about 67. So yeah, there you have it. The LabVIEW and myDAQ setup was successful here in being able to take that temperature data acquisition in the form of a resistance using a thermistor. Thanks everybody for watching. Hope you enjoyed it, and we'll see you in next week's lab.